Thank you guys very much for your time here today in coming to this session on building a smarter organization powered by machine learning. My name is Tom Godden. I am an enterprise strategist with Amazon Web Services. The enterprise strategy team is a team made up of 15 former CIOs and CTOs. And we spend time with our strategic accounts advising them on not only our experience, but in the conversations that we have with over 1,600 enterprise customers a year on various different trends and activities that they are doing to make that cloud transformation, to make that digital transformation. And in the talk today, we'll talk about to make that move into using machine learning. We'll spend some time really diving into today the myths and the realities of machine learning and to understand it a little bit better. Terms such as artificial intelligence, they might conjure up, for those of you who are maybe my age, the images of 2001 Space Odyssey. If you're familiar with the plot of the book, you know, it is about a malicious artificial intelligence. It's called HAL 9000 that had a human-like personality. This representation of artificial intelligence with a near human capability still permeates the popular psyche of industry today. But that view is tricky questions. We find that the average organization will finally be solved using AI are a little bit different from what we see with that. AI cannot automatically improve your profits. It cannot automatically improve your customer satisfaction. It cannot increase product availability. But for several decades, this has been the belief that people have had. I want to move forward here to a quote from Arthur C. Clarke. Arthur C. Clarke popularized the view that technology can often be confused with magic. I think this is the case that we see today with artificial intelligence. For instance, it's not unusual to hear customers say that their organization is going to be powered by artificial intelligence, but yet struggle to understand why they're even doing it and what it even means. We're 2 minutes into the presentation, and I've used the phrase artificial intelligence a few times. It can feel, though, sometimes it might be like we're Dorothy in The Wizard of Oz with our red shoes. I don't have red shoes on. And if we just click our heels enough times, that we'll be able to get that transformation that we want. Every decade or so, there's this new technology that comes along, that silver bullet that's promising and pledging to, my slides are auto-advancing. So please hold on a moment so that they don't auto-advance anymore. There we go. But there can be a technology that comes along every few years that is that silver bullet, and we're seeing that with machine learning. So today we'll highlight some implications of how and what you need to consider in order to be successful with artificial intelligence and machine learning. We'll share how astute organizations are now embracing machine learning and artificial intelligence, and we'll dive deep into why machine learning is a team sport. From this, I hope that you'll understand how to implement artificial intelligence and how you can help build a smarter organization built upon machine learning. There's always something, guys. We're going to get there, though. Stay with me. There we go. So this is a great quote by Jeff Bezos, founder of Amazon. Customers are always beautifully, wonderfully dissatisfied. He also says that, you know, the thing that is non-replicable by your competition is speed and agility. The ability to move fast, the ability to be first into a market segment. Nowhere is agility more important than being able to respond to your customers' needs. And machine learning is not only creating capabilities for us to do that, but it's rising expectations for our customers on how to be able to do that. My clicker isn't working, but we're going to get through this. So today's customer expectations are changing. You know, customers want things that are more relevant to them. We're shifting from a period of mass production, from a period of when we did customizations, to wanting to move more towards personalization for our customers. How many of you who don't live in an apartment get mailers in the mail for, you know, lawn mowing services? Maybe you're a vegetarian and you get the meat, fest pizza deals that come to you. Customers are expecting more personalization for the work that you were ultimately doing, for them. Not only that, but they're also expecting that we are increasing the speed at which things are done. Customers don't want to wait days or hours, for a mortgage loan to be processed. They expect it to be able to be done instantaneously and provide them that answer. They're also looking for that efficiency. Customers want you to operate at their speed, to be able to create solutions more rapidly and faster for them. So we'll talk here in the beginning about the father of artificial intelligence, Alan Turing. And I like the quote here: "A computer would deserve to be called intelligent if it could deceive a human into believing it was human." This was the original test at whether or not something had artificial intelligence. And, I believe that Turing was right in this regard, but it also means that we need to look at it in some broader terms to really be able to understand that. So let's start dissecting into what is artificial intelligence and machine learning. Let's start with artificial intelligence, but let's start talking about a little bit of what it is not. Artificial intelligence isn't our little robot that we've seen in movies like Terminator, like we've seen in movies maybe like Minority Report or others. We've barely begun to understand the hundreds of billions of neurons inside of our brain and how they operate and interact with one another. To think that we could recreate that in silicon, to be able to teach the computer how to be curious, how to be ethical, how to be sensitive, to how to be inquisitive. It'll happen. It's decades and decades away from ultimately happening. AI used in organizations today is different from this pure AI. It takes a small slice of what we make decisions about within a particular topic and codifies this with an algorithm or a program to be able to perform capabilities like text-to-speech or speech-to-text, to be able to do image recognition, to possibly be able to do things like chatbots. These are pre-programmed algorithms. The computer isn't really thinking. It's responding. It knows that if you give me this as an input, I'll give you that as an output. It does it every single time. It just seems intelligent, but it's not really learning. It's not really behaving intelligent. It's a codified algorithm inside of the computer, and they work incredibly well. LexisNexis has been able to do this to automate their legal research in their briefs. LexisNexis, for those of you who are familiar, is a content provider and aggregator of legal research here in the United States. And they were able to take all of their legal pleadings and findings, over 27 million of them, and to be able to build a solution that uses artificial intelligence that canvasses all of that information using some cognitive capabilities to be able to take research that used to take up to 5 hours and be able to do it in 11 seconds using artificial intelligence. The next segment here within artificial intelligence is a subset. It's what is typically referred to as machine learning. And machine learning is the term I'll use through the rest of the presentation. It's more of a generic term. But machine learning, it helps computer systems learn without that explicit programming. It uses probabilistic determination to be able to come up with a confidence score on what it believes the answer will be, based upon a variety of input data, your model and how to interpret that, and it comes out and goes, it's 90% chance that that is an orange sock. And you code and say, if it's 90% confidence, are you going to believe it? Or are you looking for it to be 99%? That's what you decide as you go forward to build this. As we look at machine learning, that input, that feature extraction capability, ultimately to that prediction and that output, an enormous amount of time will be spent in gathering that data in what we call data wrangling. In fact, gathering the data for your machine learning will probably take up 80% of your time. Building the model will probably take only 10% of the time. Testing the model, the remaining 10% of your time. Gathering the data, getting the data right, the ultimate garbage in, garbage out scenario, is certainly true as we look at machine learning. Each of these things, as I mentioned before, has a deterministic probability of it. So if we were able to train the computer that a vehicle that weighs 25,000 pounds and is yellow, we'd be able to get to a point and go, well, it's probably a school bus. It's probably a United States school bus if those are the capabilities. That's the type of thing that we're trying to get to with machine learning. There are a couple different types of machine learning with specialities within each one. The first is supervised learning, then unsupervised learning, and then reinforcement learning. Let's dive into each one of these here very briefly. The first one is supervised learning. It's the most basic model. And really what's happening is you're training the computer how to interpret because you know the outcome. So you know the inputs, and therefore you know what the outputs are, and you can reward and tell the computer that it has done what you expected it to do. With a classification model that you saw here that worked first, the output is ultimately known. So you're able to tell the computer cotton socks typically are orange, and so it's able to determine is the sock cotton or is it nylon, and therefore it's able to say, okay, you told me that cotton socks are always orange, I'm going to be able to assume this is ultimately orange. But it's supervised. You're telling it what the outcome is. You know that what the outcome is for this, and you're doing a very basic classification after having that data and that information organized. The second one is a regression. You're able to provide it a series of input data, maybe the square foot of a house, maybe how many bedrooms the house has, the geography that the house is in, and it's able to go, okay, well, for a 2,000 square foot house, it's $2 million. 2,200 square foot or 2,100, it's 2.1 million. You're able to probably predict what the 2,300 square foot house is. Very basic model, but this is regression in forecasting. Now, one important thing to note as we get into regression here, though, and we talk about it, is you need to be careful. If you train your model using data from Paris, from London, from Tokyo and New York, and then you go to predict this, the cost of a house here in Las Vegas, you're probably going to be astonished at what it thinks the housing cost is here in Las Vegas. So it's an important lesson to learn as you look at your models. Models need to be well understood. They need to be tuned. Models also are living, breathing things. You don't build the model, declare victory, and go away. You constantly are refining and updating and evaluating that model to make sure it's giving you the predicted outcome that you expect to give you. Domino's Pizza Enterprises, which operates a number of franchises throughout Asia and in Europe, is actually doing some work here within the supervised learning space that's really kind of out there and crazy. They have a project called Project 310, and their goal is, well, you're still ordering the pizza online before you've even said, I'm going to order. They look at your past history as an individual and the types of things you order and go, every time you show up on our site, you actually order pizza. And you actually order a medium pepperoni pizza. So we're going to start making that pizza, even before you bought it. Because they were trying to get, how can we get it there fast? Get it to you hot and available for pickup in under 3 minutes or delivered to your door in under 10 minutes. So they're using that type of forecasting to be able to have that probabilistic determination of, well, how confident am I that this individual is actually going to be able to buy the pizza? This has been a great success for them and is a very basic but a great version of this. Unsupervised learning is a little bit what it sounds like. But with unsupervised learning, I don't necessarily know the outcome. I can't codify and completely tell it what that outcome is going to be. So the first one that we have is a clustering type of one that groups things by similarity. And the computer will attempt to do its best to do these, and then you're doing a reinforcement of it at the end to be able to help it understand that capability better. Another one is association. For the film fans amongst you, you might recall this being the technique used by Alicia Silverstone in the movie Clueless to be able to find out what are the types of clothing that are typically worn together. So on day one, it doesn't know that the blue pants go with the green shirt, but over time it could start to learn, well, you always wear the blue pants and the green shirt. And so it could start to make a recommendation based upon behaviors and past history that you have. The other one is anomaly detection. Looking for things outside of the trend line. Looking for things that don't potentially belong. Like for instance, this example of chihuahuas and blueberry muffins. Trying to find the chihuahuas. By the way, it's chihuahua, or blueberry muffin, chihuahua, blueberry, blueberry, chihuahua. It's surprising and disturbing how identical the chihuahuas look to blueberry muffins. But it's trying to find the outliers. It's trying to find, well, what are the things that deviate from the norm to be able to do that anomaly detection? And as you can imagine, there's no way for you to tell it what that is. It's a learned behavior over time. It's learned behavior without a known outcome in getting to that. This is what Celgene is ultimately using for their advanced pharma research. Commercial drug costs are enormous to be able to develop $2.5 billion in an average of 10 years to bring a therapeutic to market. Celgene is using unsupervised learning to find relationships between disparate data and the results within that data of their clinical trial studies to be able to create therapeutics for less expense and bring them to market faster to do so. The last type of unsupervised learning is reinforcement learning. This one might be one of the ones that's most well known. This is where we're getting into autonomous driving. But do you ever think, how do they teach the car how to drive? I mean, how do you tell the car every possible thing that could happen on the road for it to encounter and what it should do and shouldn't do? It's actually an interesting hypothesis because, as you can imagine, it uses artificial intelligence, image detection, to be able to detect this is a car, this is a person, this car is moving, this car is turning. And what you do is they create a virtual world, because we don't want the car to try this out on the road, and it takes certain behaviors. And once it's done the behavior, you give it a positive reward or a negative reward. Did it do the right thing? Did it do the wrong thing? Did it run through the stop sign? Or did it stop at the stop sign? Did it stop too early at the stop sign? Or did it go just far enough? And so you're constantly running these cycles, going through reinforcement learning to be able to be giving it thumbs up, thumbs down, giving it kudos, and the computer gets its feelings hurt, and it tries to do better when you keep telling it you're doing a bad job. And so this reinforcement learning is a very typical behavior that we see again in autonomous driving. But in a great example that I like of this here is with Woodside Industries in Australia. They're using it because their plants used to require a great deal of proactive maintenance for their power and industrial plants. It took a long time and they would become offline. And part of it was they were very complicated to shut down the plants. It was hard to do. You had to do certain things in absolute sequence in a very precise way to do it. And so they wanted to start having robotics be able to do these things. And so they used reinforcement learning to train the robot to know if it grabbed the right valve and if it turned it just far enough to be able to deactivate it and turn it off. And that the robot then went over to the next valve and turned off the next valve to do it. Not only were they able to maintain their plants and operate their plants more effectively with it, but as you can imagine, they were able to do it a lot safer because we weren't putting a person in there to be able to do this. So although autonomous driving might be one of the examples, there are other ones that ultimately exist here as well. The next one that we get into is deep learning. And I'm not going to spend as much time talking about deep learning here today. It is a electronic equivalent of really looking at the brain's neurons to incrementally learn massive amounts of data and digest massive amounts of data in a deeply interrelational type of thing. If A is equal to B, but B equals C, but D is greater than F, and if it's a Tuesday, then the result, it's a deep correlation and relationship of multiple input points. It is becoming more evolved and becoming more used, but I expect it's not the place most of you will start. So we're not going to spend as much time on that. I do want to share and bring a great example of how this culminates and all comes together with Amazon's Just Walk Out technology. Now, if you saw Adam's keynote presentation today, he shared just a brief little bit of this. And for those of you who are not familiar, the idea was to reinvent retail commerce so that you could pick up items off of the store, put them in your shopping cart, put them in your briefcase, put them in your back pocket. Didn't matter where you put it, just mattered that you took it. And if you decide later, I don't think I want it, you could put it back on the shelf. And through machine learning, through computer vision and a variety of different things, it operated and watched all of those steps so that ultimately you could just walk out and the computer would provide you that bill. I want to share an example and share a quick video of how all of this comes together.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go.
Okay, of course I had to use an Amazon example at the end, but I didn't have to. I decided to. It's just a great example of bringing together so many of these pieces, the supervised learning, the unsupervised learning, the artificial intelligence, to really get to a point where you've completely reimagined something that hasn't been there before. And as we look at this, why now? Why are we seeing this push into machine learning now? It may not be much of a surprise to many of you in the room, but we're seeing this because of the massive amount of compute. Cloud has completely changed the game. You heard Adam also talking about it today. The volumes that we're needing to deal with to be able to do this compute has completely changed. The connectivity to pull in all this data from all these sensors, not only to pull it in, but then to send it back out to act upon it, to tell that robot in the factory what to be able to do. And then the massive, massive, massive amounts of data that is needed to be able to drive this is ultimately unprecedented today. There's a great quote from Andy Jassy, the CEO of Amazon. Most applications in the fullness of time, we believe, will be infused some way with machine learning and artificial intelligence. I think that this is true, but we'll get to why this is a cautionary tale for where many of us are here today. But we strongly believe that this is where the future is ultimately going. But like many things, I want to talk to you about general purpose technologies. As we looked at factories that went from water wheels to being steam powered, that steam power created new ways to do the factory. But it wasn't the technology necessarily that changed the factory. The technology, steam powered, allowed us to reimagine how the factory worked, what the processes were. Sure, they no longer had to be by streams and rivers and waterfalls, but it allowed you to rethink how to lay out that factory, how that factory could operate and be different. So again, it wasn't the technology necessarily that was the difference maker. The technology allowed you to reimagine how things are done. This is the same thing as we start to move from steam powered to more mechanical, types of things, where we move from those mechanical hydraulic types of solutions into that next generation of reimagination with small motors inside of all of our consumer devices. It's not always the technology. It's not machine learning that is going to make the change. Machine learning is going to allow you to reimagine your business processes, to reimagine how you interoperate with your customers to do that. This also creates then this, what we call the data network effect. Machine learning is really interested in this, in that more data allows you to create better algorithms. Okay, better algorithms allows us to have better engagement and have happier customers, whether they're internal customers or external customers. And then ultimately those happier customers, well, they create more data, and on and on and on and on. This is a very unique flywheel. We love our flywheels here at Amazon, and machine learning has an awesome flywheel and allowing you to continually grow and improve. There is also the exponential impact over time that you're all familiar with technology. Technology is very unique in this regard, in that adding incremental users on top of your solution is easy, it's incremental. It's not a heavy lift to be able to add those. It's unlike other industries that ultimately operate. So how do we think about this? Let's talk about how we mobilize on this. We use this framework in a lot of different areas within our team, but we try to break things down into what are the mindset changes that need to occur, what are the skill set changes, and lastly, what are the tool set changes? What is the technology? Technology's last, okay? It turns out the carbon-based life forms are more challenging than the technology is in order to drive true transformational change. So let's start and talk about the mindset. We see these type of mission statements often. We're going to build a AI-enabled, machine learning-powered, data-centric organization that embraces customer centricity through global business synergies. Okay, other than being an enormous amount of word salad, it also doesn't mean much. You know, we talk and say you should have a business vision and a business strategy that is well known and understood by everyone in your organization. And machine learning, although a part of it, shouldn't be the driving part of being able to do that. You know, as we look at your business strategy, you know, AI and ML are being used to improve customer journeys, to improve customer satisfaction. You know, those algorithms are being built every day, but they should be as part of an overall business strategy. Your business strategy should be, we want to launch a new product. We want to go into a new marketplace. We want to increase customer satisfaction. We want to have a larger share of a specific market. And we believe using machine learning as a segment of it, you know, could help us achieve it. You know, I was working with a large manufacturing company, and the CEO told me that he gave an objective to each one of his executive teams to have a machine learning initiative next year. And I said to him, why? Why'd you do that? He goes, well, because we're trying to digitally transform it. We're trying to be modern and do these things. And I said, okay, I mean, on one hand, your ambition isn't completely wrong, but it should be, again, to solve the business problems. That you understand that using artificial intelligence and machine learning is what is needed to be able to create these solutions. And that it's ultimately the right tool for the job. Oftentimes we see machine learning being used by organizations when quite simply data analytics would do. Might be kind of fun to write it in machine learning, kind of cool, something new, play around with. But simple data analytics and simple reporting might provide you the answer. In which case, you know, don't have that proverbial hammer in your hand and going around and trying to peel an egg using the hammer. It's not going to work. Well, it might peel the egg. It's going to smash the egg also. So find the right reason to do these things. Be grounded in creating business value, not in just saying we need to do machine learning because all the cool kids are doing machine learning. Find a better reason for it. You also, as senior leaders within your company, need to take a leadership role here. You need to fuel that positive momentum by ensuring that sufficient experiments are able to be conducted in this machine learning space. You know, you need to ensure that great ideas and successes are scaled quickly. You also appreciate that data and machine learning doesn't recognize the organizational structures created over 200 years ago and perfected 100 years ago within the Industrial Revolution. Instead, what we talk to organizations about is that building those autonomous cross-functional teams that are known of a business problem and are empowered in how to go after solving that business problem is how best to succeed. We also see the value of accurate data. Remember, I talked about earlier, 80% of your time is going to be spent in data wrangling. A common mistake that we see organizations doing, and I did this, so I can fall on my sword, is saying, okay, step one, we need to go get all the data across the company. Just gather it up, throw it in a data lake. Step two, we're going to clean the data. We're going to master this data to an inch of its life. Make sure it's all good, clean, non-duplicative. It's going to be great. Okay, well, 7 years, $35 million, and the severance of one CIO later, you may actually get done with that, maybe. You're also going to deliver zero value between the day you started and that day 7 years from now. Instead, what we suggest is incrementally bring in that data. Incrementally clean that data as you're looking to solve those business problems and those challenges that are brought to you with machine learning. So yes, value the data, but only go after the data that you need to answer the question that you need to have. Resist the temptation to do those large data projects. And ultimately, we talk about this in our data-driven enterprise presentation around creating and scaling a data-driven culture. And to do that, we talk about 4 E's. And the first one is engage. And what we mean by engage is get that senior leadership to engage in this project. Have them participate in using this. When you come out with that new capability, have them stop using that old report. They're voting with their feet. They're showing you their true intentions. Have them engage and help support these initiatives going forward. The next one is educate everyone on the effective use of data. We see organizations that are successful in their early AI ML initiatives spending almost 50% of their budget on training of people on the effective use of data and how to gather the data and prepare the data in these. The next one is enable frontline action on the data. I hear a lot, and you probably have heard it too, the popular buzz phrase, I guess, we want to democratize the data. I don't care if you democratize the data. I want you to democratize the decision making made upon the data. I want you to allow that frontline person who has a customer on a phone right now that is complaining about something that's going on, and the data is informing them of what the step to do, to be able to act upon that and not have to go back up that legacy hierarchical change and ask for approval to be able to do it. So sure, democratize your data, make it available. Make it available so people can build new models, but make sure you match that with the ability for people to act upon that data. And then eliminate blockers to becoming data-driven. Help push to shut down those data silos. We had this within my organization as well, where people didn't want to share data as readily because they didn't trust that people would understand and interpret the data the right way. Spend time with those people, allow them to be those data masters, to be those people who can then set the quality of the data that is ultimately being used and help train people in that usage of that data. The other thing that's important is answering the question of what's in it for me. And we have 4 actors here, and I want to start first with the customers. You're all likely seasoned veterans, and you've been around this to know that the old adage of if you build it, they will come may not necessarily be true. And this includes your customers and society at large. History repeats itself with any new technology that is not well understood. People resist it. It's incumbent upon you as leaders to be transparent about what you're using this technology for and why you're using it and how you are using it, if you expect your customers to have the confidence of it. Likewise, as you look at society, the ethical considerations around machine learning and artificial intelligence become important and require that same transparency and that same commitment. As you look into this a little bit deeper into the ethics, whether or not things are fair, whether they're private, whether they're explainable or secure, becomes increasingly important. Let me pick on one of these here very briefly as we talk about the explainability. Even in today's organizations that may not be perfectly functioning, most business decisions are explainable. Now I know you're going to laugh and tell me you can all pick on one that's happened in your organization lately that isn't explainable. But for the most part, things are explainable. You know why a project was approved or not. You know why a loan was approved or not. You know why decisions are made. When we're going to start turning over the loan approval process to a computer, this becomes a lot more complicated to explain why did I grant a loan to one person and not another. In particular, to make sure that I get my biases that may have been built up historically over time that I've now brought into these algorithms unconsciously that are now affecting those decisions that are being made. So spending time in getting the ethics right, the understanding to be able to have that explainability for your stakeholders is more important ultimately than ever. The next thing I want to talk about here a little bit is skill set. The first one is with leadership. You got to understand as a leader, your challenge is to, drive this initiative forward. And we see the vast majority of organizations having their machine learning initiative driven from the C-suite. Over 85% of the organizations that we work with have their machine learning initiatives driven by someone within the C-suite. But 1/3 of the organizations say that they're not prepared and they're not ready for this. So this still becomes an enormous challenge as leaders to be able to do this. You need to engage people in the journey. You need to bring people along and explain why they need to be part of this change. You need to be empathetic in the changes that are ultimately being made is part of this. Because the next one becomes even more challenging. Employees. Now, yes, there's the concern as we talk about employees, with employees believing, well, are you going to replace me with a robot? The truth of the matter is, in some cases, maybe. But you as a leader need to be prepared to explain, but that's going to free you up as an employee to take on even more highly valuable solutions that need to occur inside of our organization. You see, companies might be able to understand, and employees are able to understand, what's in it for the company to be implementing machine learning. But what they need to understand is what's in it for them. We call this the frozen middle. Your junior level people, new to the company, they're open for anything. You know, got their whole careers ahead of them. Sure, put me in, coach. I'll do whatever you want. Senior level people, it was their great idea to do machine learning. They're bought in. It's all the people in the middle. All the people in the middle that have mortgages and rent, kids to send to college, who have a historical, have a history of doing it one way. These are also all your people who know all the hidden information and logic and data and behaviors of your systems. They're probably the ones who know whether or not that customer is going to churn or not. They're the ones that you need to help you make this transformation. So make sure you spend the time with them and explaining what's in it for them. Make sure you share with them how you're going to help train them to do that. The training is an important part in that. If you told me tomorrow, hey, Tom, your job at AWS is changing, you're going to become a French chef. Okay. Interesting. Big career pivot. Long conversation with the wife coming when I get home. But the next question is, how are you going to help me become a French chef? I mean, I can microwave water with the best of them. Okay. But you want me to become a French chef? Show me how you're going to invest in me so I can succeed. Otherwise, I'm just looking at this as guaranteed failure. And then what do people do? Well, they start to slow down. They're implicitly holding back. You need to get all of their minds, all of their input into helping drive this change. So make sure you make it clear and important to them of what this is. The next one is, you're going to have new roles. One of those roles that we get into ultimately is that data scientist. I'd love to see a data scientist with the wizard robe and the wand, but the data scientist. And they are actually, people who are highly skilled and use data, but they're not the only people you need. Again, you need the domain experts. You need to get the people who know whether or not that customer is going to churn. We see a lot of customers looking to outsource this. Maybe you don't have this as a skill today. That's okay. But I encourage you to have a strategy to build these people and have them be within your organization as well. Don't become over-reliant on someone else being that data scientist organization, for you. We also see situations where, that you need to bring in a lot of different skill sets and capabilities into these. Over 80% of that work, remember we talked about, is around that data wrangling. And you need those people who can think about those different things, including thinking about ethics and, it transcends the technical skills. We focus a lot on that data scientist, but there are a lot of people up here, that business translator, that communications person, that person from legal to help manage and make sure that you have those machine learning ethics built into your solution. But training also becomes an important thing, and there's a couple different ones here that we have. Our machine learning university, the ML Essentials capability that really helps make machine learning well understood by more of your traditional business person, as well as certification within AWS. I encourage you, invest in this training. I wish I had done more as a CIO in this area. I cannot encourage it enough. Another exciting one, and it's going on here at reInvent this week, is with Deep Racer. A great example here is with Morningstar. Morningstar, for those of you who are familiar, a company here in the United States that does a lot of financial services capabilities. They invested in this very significantly to have 445 employees participate in a Deep Racer racing league. And for Deep Racer, for those of you who aren't familiar, is basically you're taking an autonomous car, using a lot of these skills we've talked about today, supervised, unsupervised, and certainly reinforcement learning, and you're applying those to get the little car to drive around the track really fast. It's something that can start to demystify this for not only your technical staff, but the business people as well. Gives them hands-on learning. So not just classroom learning, which is good, but allows them to apply it hands-on. It's also kind of fun. It's a fun thing to do. Talk to your account managers about this. It's a service we offer at AWS. It's a lot of fun. They're racing leagues. The championship is going on, I believe, down at the MGN this week. So I encourage you guys to do that. We also, as we look at skill sets, suggesting that much like you build a cloud center of excellence, you may look at building that machine learning center of excellence. Often these teams are virtual teams, but they're the teams defining your standards and your capabilities for machine learning. They are that cross-functional team of those people we spoke of before, both technical, data scientists, machine learning, cloud engineers, but also those business people, the people from the legal departments, the people from communications and that type of thing, defining the standards of what you will do. The last one that I mentioned, again, was tool set. Tool set is an interesting one. With cloud, this has really changed quite a bit. It's become something where the cloud is able to really redefine the ability to do this in the fastest start, quickly scalable, and redefined world. So obviously you're here today, but cloud plays an enormous role in being able to enable and to fast start your machine learning initiatives. Liberate your data. Data lake, data lake, data lake. It is the fuel for that machine learning engine. Without discipline on how to systematically capture and manage that data, though, you'll have no future in machine learning. So invest in how you do this. But I want you to use the philosophy of governing to enable versus governing to restrict. Make your data lake easy to use. Make the data sets easy to use. By doing that, you'll also be able to ensure that they follow the security protocols, the privacy protocols, various different regulatory things that you need it to be able to do, and grow that data lake ultimately over time. And then using the AWS machine learning stack, again, Andy covered this here today. For us at the top of the stack are the prepackaged API-based AI services that are available for people to be able to call. The middle stack being that development tool capability around AWS SageMaker that allows you to manage the data, allows you to manage the models. And then down on the bottom, a series of different AI and ML frameworks for people to be able to use who really want to get into the nitty-gritty of the data and to be in full control of those capabilities. There's a great quote here by Ritu. Companies will adopt AI not just because they can, but because they must. I hope that as we've gone through some of this here today, that you've seen the importance and the need in why we need to get to more personalization, to be able to get to that speed, to get to the efficiencies that people want, that you have a better understanding of the different types of artificial intelligence and machine learning, and then of the skills within mindset, skill set, and tool set to help you be successful. But let me leave you with a couple last steps. Again, be clear on the why. Be clear why you're doing a machine learning project. Please have the reason why be to create business value. Don't just do it because. Don't do it because it's neat. Find something and be clear on the why. Get alignment from your stakeholders. Sounds obvious. You guys are all seasoned veterans, you probably know this. But this is true, especially when you're forging into new territories and new frontiers. Make sure that that squeaky wheel on the C-suite team understands why you're doing it. Otherwise, it just drags it down, especially when we're trying to transform with this new capability. A great tool that was just recently launched here by AWS, you can get the QR code here, is the AI Explorer. It provides a library of use cases of how our customers have used artificial intelligence to have a specific business outcome. It's not a technical tool. It's not going to tell you that they used Lambda or Aurora. I mean, I think it does a little. But the point more is it inspires the types of things. How are people using it? What are the problems that people are trying to solve? so that you can explore these and you can take them back and share further examples beyond the ones I shared with you today to help getting people thinking and imagining of what those new capabilities could potentially be. It's a great tool for this type of thing. Start small, think big. You know, you might have that Formula One race car, maybe next year, it'll all be running around here in Vegas. You know, you pour water into the engine, you're not going to go anywhere. So have those big ambitions, but ultimately start small and think big on that. And hopefully you've heard me, I've made the point several times here in the presentation, technology is the enabler. It is not the objective. The objective is not to implement machine learning. The objective is to solve a business problem and realize machine learning is the best way for you to do so. The last thing that I want to leave you with is a couple steps to take. So again, with defining that why. Define a problem or an opportunity. I like to tell people when they're doing this, define that problem in one sentence. There's no punctuation in problems. Okay, a period at the end. Okay. If it is more complicated than one sentence, it's too complicated to start. Okay, you need something that says reduce customer churn, period. Got it. We can get to work on that. So make sure that that problem is well understood and that it's easy to get going. Assemble that team, cross-functional team. Don't respect those hierarchical boundaries that came from the Industrial Revolution. I'm going to hold you back. Cross-functional, autonomous, self-contained team. Train them on the new capabilities. Develop your hypothesis on how we're going to reduce churn in the example that I have. Find the data, just the data you need to be able to reduce your customer churn. Then go ahead, train your model, test your model, develop a new hypothesis, lather, rinse, repeat. Last couple of things. As I mentioned, I'm part of the enterprise strategy team. Several of my colleagues have some great presentations. You probably all have your calendars full, but if you don't, there's a lot of great presentations on a wide variety of topics that several of my colleagues are giving here over the next couple of days. I encourage you, if you have time, to take a look at those or go get them online when they're made available. If you like to read, several of my colleagues have written some books on a variety of different topics around digital transformation and cloud transformation. Yes, they're all available on Amazon.com. What'd you expect? I think they're available elsewhere, but these links will take you, I guarantee you, to Amazon.com. There's some really fantastic literature and information here. And then last thing, some additional resources. You can connect with me on LinkedIn. I'm happy to share slides with you. I'm happy to have a further conversation with you. We're a non-billable resource from AWS. How often do you hear that? We will continue this conversation with you. We will continue to help you on this, but we also have information that we've published on our executive insights. We have a variety of different podcasts. We also have in the bottom right-hand corner our enterprise strategy blog, where we write hundreds of blogs a year as a team on a variety of different transformational topics that you guys might find interesting. So with that, I appreciate the time that we've had a chance to spend today, and that you guys worked through some of the presentation challenges in the beginning. Thank you. As we've gone through some of this, please remember to fill out your session evaluation forms on it. We do have just a few minutes if there are any questions.